Hello, I'm Todd Benedier. I am the Director of Workforce Development with Solar Landscape. We are a New Jersey-based commercial solar company. We're actually the largest owner and operator of community solar in the state. And I'm here today to talk to you about the energy industry. So today we're going to talk about our current energy scheme, how we generate electricity, what the implications are on our environment, and then we're going to see why we need to kind of transition away from our current methods into something a little bit more sustainable, into something like solar or wind and a little bit greener. So where does our electricity come from? If you were able to kind of shrink yourself down into a tiny little speck and go into an outlet at your home and then fly through the wires, you're going to end up at a place called a power plant, most likely. That's the way our current system is run. We have these large generating stations that are typically far away from populated areas, and they will distribute the electricity far distances, and then we can utilize it in our homes just as we would in our everyday lives. And we're very fortunate to live in a country where we have very reliable electricity. But most of us don't even consider where that actually comes from. So how is that made? What are the sources? Well, in America, we have a fairly wide portfolio of fuels that we utilize in order to generate electricity. We utilize a lot of coal, a lot of natural gas, a lot of uranium, which is the main source for nuclear power, and then we have some other mixtures in there, such as hydroelectric. We have a little bit of wind and solar that's growing, and you'll see when you look at this graphic from the International Energy Agency, you'll notice that our portfolio of energy fuels has actually changed over the last decade. You can see that there's a baseline, so the nuclear power, that hasn't changed that much. The hydroelectric, that hasn't changed that much. But the coal has gone down significantly, and the natural gas has actually increased. And the little tiny lines on the bottom, the renewables, those have grown fairly significantly over the years, but they still only account for a very tiny portion of the electricity that we generate in the United States. So to give a little bit more perspective on that, here are the numbers that go along with that graph. And you can see that the amount of coal has decreased at actually more than half, while the amount of natural gas that we utilize and the amount of electricity that we generate from it has almost doubled. And then take a look at the amount of electricity that we produce from solar. It's a very tiny amount, especially in comparison, but over the last decade, it's grown 50 times, which is pretty significant. So we're going to talk about how that came into being and why that is in the next episode. So some of the incentives, some of the programs that have helped solar grow. Today, we're going to focus a little bit more on the technology, though. So going back to those types of fuels that we have, let's figure out where they came from, right? So the big ones that we utilize, and in New Jersey, our portfolio is kind of extensive, but for the most part, we have about 52% of our electricity comes from nuclear. Around 42% of our electricity is generated from natural gas. And then the remainder, 6%, is broken up about half and half between coal, around 3%, and renewables, around 3%. So in renewables, they actually have some biofuels, some waste production, as well as solar and a little bit of wind generation as well. So when we look at the types of fuels that generate most of our electricity, uranium, which is the supply for nuclear, coal, and natural gas, that accounts for over 96% of the electrical generation in the state of New Jersey. And when you look at where those sources come from, they all come from Earth, right? We get them from the ground. Coal is mined from the earth. You have to dig a hole, either create a mine, or in some cases, they actually remove the entire mountain, called mountaintop removal. And then they process that, they place it on a train, they transport it someplace to a power plant, and then we'll talk about what happens next. But same with natural gas. They get it from the ground, it is extracted from the earth, placed in a pipeline, and sent and distributed to a place where it can actually be refined and utilized. Uranium, also an ore, comes from the earth. You mine it, you take it out, and then you refine it. And there's only actually one place in the United States where they can take a uranium from the earth, the ore that comes directly from the earth, and then create enriched uranium that can be utilized in the nuclear power plants that are located throughout the United States. And so that transition, that transportation has to occur before it even gets to the power plant itself. Now, once at a power plant, That uranium, which by the way is super energy dense, in fact a pellet about the size of an eraser on a pencil is the equivalent of about 149 gallons of oil, about 17,000 cubic feet of natural gas, or about 1 ton of coal. That's pretty significant that you can get that much energy out of such a small piece of material. And that's one of the main reasons why we like to utilize nuclear, is because it is so energy dense. And so that refined, processed uranium goes into a nuclear power plant, and inside of the reactor, a chain reaction occurs in which that uranium is bombarded with stuff and it breaks down, and it's a super advanced process that it actually goes through, but it's nuclear fission, so it's actually one big molecule, or one big atom rather, that's broken apart into smaller ones, and when that happens, a good amount of energy is released. And so we take that energy in the form of heat, and we use that to heat water. Now, almost all the traditional power plants use that same concept. They use some source of fuel to heat water, and when you heat water, it's going to become steam. And so that steam creates a pressure. It's inside of this big boiler, and the pressure builds, and it goes through a system of pipes, and those pipes with the steam press on what's called a big turbine. And the turbine is a large, advanced pinwheel, basically. So when you blow on it, when you apply a pressure from a gas, it spins around. And in the United States, we spin them around pretty quick. We go 3,600 rotations per minute, very fast, and that gives us the frequency of electricity that we like here in the United States. On the other end of that turbine, you have what's called an electrical generator. And the electrical generator is just a giant electric motor, basically. And so it's copper coils inside of a magnetic field, and as you spin that around, electricity is created. So you're taking the chemical energy, or the nuclear energy in this case, from the uranium, you're transforming that into thermal energy, applying that to water, giving it, creating some steam, creating a mechanical energy in the spinning of the turbine and the spinning of the generator, and then that becomes electrical energy that we can then transform and transmit and then distribute to our homes, where we can actually use it when we plug in our appliances into our outlets. So that's nuclear. When we talk about coal, it's pretty much the same process. We take an ore, a rock out of the ground, and we refine it in a way that it's useful for us. We bring it over, we transport it some way, typically on pretty long cargo trains, and then we bring that to a power plant. It's heated, and then that heat is used to boil water. That water turns into steam. This steam creates a pressure. It pushes on a turbine, it spins a generator, and then electricity is generated. Natural gas is the same thing, except instead of pulling an ore out, we pull a gas out, send it through a pipeline, and then when it gets to the power plant, it's burned, creates heat, boils water, spins a turbine, connected to a generator, and electricity comes out. So that's most of our electricity is generated through that amazing physical and chemical process that I just talked about. Now, we have to figure out what's so great about that and what are some of the downsides to that. So it's obviously great because we know that uranium, for example, is super energy dense. We know that natural gas is fairly easy to get and transport. We don't have to use trains. We can create pipelines, and it's fairly clean burning. But there are some issues with the way that fossil fuels are used and burned. So the downside of nuclear is that it actually creates some nuclear waste. And that nuclear waste, we don't really know what to do with it at the moment. We're figuring out ways there, and there were some ideas that came up in the past as to how we can take that and transport it to a location where it was far away from a populated area and it might be safe. That plan kind of failed. So what we're doing now is we're taking our waste out of the reactors that's still radioactive and will be for thousands of years, and we're placing it in large silos, large containers on the sites at the nuclear power plants. So right now, in America, we have 55 nuclear power plants that are in operation with 93 reactors at those sites. And each of those sites has its own location where they're storing the nuclear waste. And we're just kind of crossing our fingers and hoping that that nuclear waste is going to be okay and that it's going to be contained. And if it's not, then that radioactive material enters into our atmosphere. It's harmful to the entire environment around it for, again, thousands of years. So that's one of the downsides to it. So far, we've been pretty safe. We have had some accidents, 3 Mile Island here in America, Chernobyl over in the Ukraine, and Fukushima in Japan. But having accidents like that happen around the world related to nuclear energy has kind of stopped the US from creating more nuclear power plants, and we're trying to figure out a reliable, a safe way that we can ramp that up. Because again, nuclear power does not produce any carbon dioxide, and that's one of the things that we're trying to avoid. It actually doesn't produce any pollutants, any emissions, I should say, into the atmosphere. So if we can figure out a way that we can handle this nuclear waste better, then that's a really great, viable option to create a more sustainable future. Coal, on the other hand, when you burn coal, you're not only emitting carbon dioxide, but you're emitting a lot of other pollutants that are going to directly impact the environment around it, as well as the environment as a whole. So things like mercury, chromium, these heavy metals that are actually entering into the atmosphere, getting into people's bodies and causing serious health concerns. That's one of the main reasons why we've actually shut down a lot of coal plants and ramped up the production of natural gas plants around the US. Because when you burn natural gas, you're not getting the same kind of emissions and heavy metals, if you will, that come from coal. And so our natural gas does, however, emit carbon dioxide. And so when we're burning that and creating more greenhouse gas and having a greater greenhouse effect, and it's impacting our climate, we do want to transition away from that as well, as much as we possibly can. So what are we transitioning to? Well, we have a lot of different alternatives. The first and the oldest, well, not necessarily the oldest, but one of the ones that we've used and relied on pretty consistently since the beginning of generating electricity is hydroelectric. So hydroelectric is a pretty efficient and pretty substantial way that you can generate electricity. It's pretty straightforward too. You essentially just place your turbine that spins around, remember, but instead of pushing steam on it, instead of boiling any water, you just take the natural flow of a river, and that current and that force will then push on a turbine, and that turbine is again connected to a generator that creates electricity and distributes it out to the grid for us to utilize. No pollution is created in the process. You're not burning anything, so there's no emissions going up, and there's actually no waste material either, like with nuclear. You don't have that issue. So the problem, or one of the issues with hydroelectric is, first of all, there's not always a place where you can put it because you need to have a source in order to actually be able to utilize it. And the other issue is that even if you do have a source, you have to dam that river. And by damming it, you're going to create some sort of a flood zone behind it. And that might displace some people, some animals, and create an environment that may not be the best or the most eco-friendly, if you will, as a result of that. So we transition to things that we can utilize in multiple areas that rely on more renewable resources, such as wind. Wind turbines have been around for a very long time. We use windmills for thousands of years, and that idea of taking wind energy and utilizing it as a source of motion has been around for tens of thousands of years in the form of sails. So we're using this wind energy to spin a turbine, which is just a really long airplane blade, airplane wing basically. And as it spins, it's again connected to a generator through a gearbox, and that generator is spinning at 3,600 RPMs and generating the electricity that we can then distribute to our grid. Pretty straightforward. Of course, the problem is the wind is not always blowing, right? So once you have that diminished capacity of wind flow, of airflow, you're not going to be able to spin those generators. You won't have the electricity that, of course, we rely on as a reliable source of our energy needs these days. The major fuels, coal, natural gas, uranium, as we spoke about, they're mined, they're taken from the earth. So they are natural resources that are actually not renewable. The earth is not replenishing them at the same rate in which it's creating it. And so at some point in time, and it varies depending on where you look and what kind of internet research you can or can't do, because it's all over the place, it varies as to how much time we have left in terms of how much we're pulling that out at the rate that we're doing. So regardless of how much time is left, it's a resource that will eventually run out. And so we need to transition away from that. We need to find something that's renewable, something that is not going to come to an end. And so we'll talk about some of the options that we have about that in just a minute, but I wanted to point that out because that's one of the major downsides of using fuels like uranium, coal, and natural gas. The other issues that we have with those fuels are that the fossil fuels, coal and natural gas, they actually emit pollutants and carbon dioxide, which is not a pollutant, but it is a greenhouse gas. So a greenhouse gas enters the atmosphere, and some of the light that should have been reflected and some of the energy from the sun that should have been reflected back into outer space is actually trapped on our Earth, causing the Earth's climate to change and causing some issues to occur around the globe that we've experienced in the last couple of years. We have more severe storms, more prevalent storms, and so things that are happening, we want to change them. We want to make sure that we're trying to avoid emitting as much carbon dioxide as we currently are. So we're transitioning away from that as much as we possibly can. The other option is solar. Solar actually has two major types of technology. The first that you might not be so familiar with is called solar thermal. Now this has two technologies, or sub-technologies if you will, within itself. The idea is, though, that you take the sun, the energy from the sun, and you concentrate it at a certain point. So that point is either on a tower, so you either build a really large tower with a whole bunch of mirrors around it, and those mirrors are reflected directly at the top of that tower. And inside of that tower, you have a heating chamber that has some sort of liquid, some type of oil, and as it's heated, because it's of the sun, because of that concentrated energy of the sun, think about taking like a magnifying glass and almost starting a fire, utilizing it. You're taking that energy from the sun and concentrating it into one particular point. It gets superheated, and then it goes through the traditional types of generation where you're using that heat to boil water, to create steam, to spin a turbine that's connected to a generator that goes out to the grid. The other idea, or the other option for solar thermal, is to actually create a trough, and within that trough you have a tube that's filled with the same oil or similar oil, and the light from that trough is concentrated onto that one focal point where that tube is. And as the oil travels through that tube, all the light is concentrated onto it, and so it gets superheated, goes into water, creates some steam, spins a turbine, and generates electricity. Again, all the same kind of end processes that you would have with a typical generating plant like nuclear, coal, or uranium. However, now the only input is sunlight, which of course we know you don't get from the Earth. It's not mined. It's a nice renewable resource with zero pollution. The other type of solar technology is called photovoltaic. Now that literally means light electricity. So you're taking the photons from the sun and you're transforming it via solar panel into electricity. That's pretty amazing when you think about it, because unlike anything we've talked about before, there are no moving parts and the only input is sunlight. So your material that's inside of the solar panel is typically made out of silicon. Silicon, yes, does come from the Earth. It is taken from the Earth's crust, but it's also the most abundant element in the Earth's crust. And when you take that silicon and you refine it and you create these silicon wafers that are super duper thin, so it's not like you're using like a lot of it for each solar cell, and then you place them into an array, and then you leave that array in its place, you no longer have to keep throwing silicon onto it, just like you do with coal or uranium or natural gas, where you have to continuously add fuel to the fire, if you will. Those panels, our panels that we use, are warranted by the manufacturer to produce electricity for 25 years. And most of them are still producing after 50. So it's pretty impressive that this form of electricity has no moving parts, no required inputs from the environment other than sunlight, and it just sits there and generates electricity for us with zero emissions. Photoelectric is really cool, and we talked about wind, which is something that we all know about, and we probably have heard of, or at least can understand the idea of hydroelectric. But there's one more technology that we might see growing and becoming a bigger industry, and that's called a fuel cell. Now, fuel cells have actually also been around for a pretty long time, but there's a lot more input, a lot more of economic stimulus that's going behind the technology and behind the implementation of this. So I am going to take a couple minutes to just quickly talk about it, because it's pretty awesome. This is a technology similar to photovoltaic in that there are no moving parts and there's no waste, there's no emissions. The only input that you need is hydrogen. So similar to silicon, where that's the most abundant element in the Earth's crust, hydrogen is actually the most abundant element in the entire universe. So that's saying something. We basically have a lot of it. The problem is that hydrogen is the lightest element. So you probably are familiar with helium. That's the second lightest. So if you have a balloon filled with helium, it'll go straight up. If you had a balloon full of hydrogen, it will also go straight up, but it won't stop. It will actually exit the atmosphere. That's how less dense it is than everything around us. And so capturing it and storing it has become a bit of an issue. But we have plenty of it. It's locked in our hydrocarbons. It's locked up in this other great thing called H2O. And we can tap into those resources and we can pull the hydrogen out and we can place it into a fuel cell. And the fuel cell will combine that hydrogen with oxygen. And when you do that, you actually create electricity when you have this fuel cell membrane inside of it. And that's pretty awesome because you also create water. So the only output that you have from this source of electricity is H2O. So I'll repeat that. You take H2, which again is the most abundant element in the universe, and you can get it from water or you can get it from hydrocarbons, and you can place it in a fuel cell, combine it with oxygen from the atmosphere. Electricity and water will come out of that. That's pretty amazing. And I think we're going to see a lot more of that in the future. In the next episode, we're going to explore the timeline of policies and all of the other events that occurred that brought New Jersey into the forefront of the solar industry. And we're going to see exactly what kind of policies and legislations are in place right now that are leading to the growth and the greater workforce and the greater economic development within this particular field. Again, thank you for your time. I appreciate it, and I look forward to seeing you next time.